Today we're looking at a second example of a hypothesis test for one population proportion. So we looked at a more than problem in the last lecture video. Now we will be looking at, well, I guess we'll find out. So again, when you look at these paragraphs, there are pieces of information that you'll always have to find. You need to find information on the sample size. So here we have a sample of 530. Then you need to find the number of successes. So here there's 54 as our success. You also need alpha. It helps you to make your decision in step 4. And then you need to know what you would like to show. So here we want to show less than 10%. And then the last thing that you need is information on writing your parameter. So that includes your population. So here our population is John Ball Park Zoo members, and then our success is if they love the zoo but don't like pets. So when I start in step 1, I just stated the population. So our population is looking at John Ball Park Zoo members. We already identified the sample. It's 530 randomly selected John Ball Zoo members. And then, as I've said in the past, it actually isn't part of step 1 in terms of what the textbook says, but I like to add a parameter definition because it helps me when I get to step 5 to make my inference. So we are trying to make an inference on the parameter p. We are going to use the word percent because that's what is stated in the problem. So percent of, and then our population. So here it's going to be percent of John Ball Park Zoo members. And then our success is those who love the zoo but do not like pets. So percent of, and our population is John Ball Park Zoo members. And then the success is those who love the zoo but do not like pets. Next, we're writing our null. And remember, you write that with capital H sub 0, colon, and we're trying to make an inference on P. So that's what we use as notation here. And then the alternative is the same. It just switches the sub 0 to sub A. And then the problem says we want to show that it's less than 10%. So here my alternative is going to be less than 0.1. It would be just as correct to write 10%, but because we have to use it in decimal form, I'm going to include the 0.1. And then your null will be the opposite. So we have less than here, so my null is greater than, and remember the null always includes the equal sign. So this is my null value of 0.1. And then we always will assume that the sampling distribution of p hat is the normal distribution, but we have to verify that by doing what's called checking conditions. And remember, to do that, both n times p sub 0, which remember p sub 0 is the notation for the null value, and n times 1 minus p sub 0, both have to be greater than or equal to 10. So here, from the description of the problem, our n is 530. So we have 530 times 0.1 and 530 times 1 minus 0.1. Both have to be greater than or equal to 10. So here we have 53. So that condition is met. And then we have 477. greater than or equal to 10, our conditions are met. Next, we're going to calculate the test statistic. And in order to do that, we will need to calculate the value for p hat, which remember is x divided by n. So x is the number of successes, and from the paragraph that's 54, and n is 530 as we discovered in letter B. So our p hat value is 0.1019. So now you may remember that the formula here is p hat minus p sub 0 all over what's called the null standard error. So p sub 0 times 1 minus p sub 0 over n. So then we have 0.1019 minus 0.10 divided by 0.10 times 1 minus 0.10 all over 530. So again, you need to practice calculating this whatever way is necessary for you to get an unrounded precise value. So I start by doing the null standard error. So essentially I do the numerator, so 0.1 times 1 minus 0.1, and then I take that product and divide by n. So that's what's underneath the quotient. So now I'll take the second and then square root. So it's telling the calculator to draw from the row above. So this is the standard error, what's underneath the numerator of the test statistic. Now I'm going to type in the numerator, the denominator, and then I'm going to divide by what I had for the row above, or my standard error. So my test statistic is 0.1458. Now, this, because it's a z, is the normal distribution. And to find p-values for the normal distribution, we are going to use the normal curve, which is centered at 0. The location of my test statistic would be approximately right here, just slightly to the right. And then because we have a less than, the area that we're interested in is going to be the area below. So when you find a p-value with the calculator, you're going second and then vars. And you want the normal CDF. So we're on the normal distribution, so we're using normal CDF. Technically our lower bound here, if you remember, is a negative infinity. And so because the calculator can't handle negative infinity, we're going to type in negative 999. And make sure that you use the negative symbol, which is below the 3, and not the minus symbol. They are different. It's not like your computer. And then our upper bound, or where the highlighting ends, is 0.1458. And then just like before, you leave these two as 0 and 1. So we go to paste and push enter, goes out to the main screen, push enter again, and that is our p-value. So our p-value is approximately 0.56. So to make our decision, we need to know if our p-value is small enough. So is it less than or equal to alpha? So is 0.56 less than or equal to, remember from the top of the page, alpha is 0.05. The answer to that is no. So because it's not, that means that the sample value is not far enough away from your null value to justify rejecting the null. Which makes sense because we had a p-hat value of 0.1019. So remember, when you fail to reject, you start step 5 by saying there. So because we didn't leave the null in step 4, so remember step 4 is about the null, we didn't leave it, so we failed to reject. Step 5 is about the amount of evidence for the alternative, so we didn't leave the null, so that means we have insufficient evidence for the alternative. So when we write step 5, we're addressing the amount of evidence. So here it's insufficient to suggest, and we're going to rewrite the alternative up here in words. So starting with P, we define P as being percent. So there's insufficient evidence to suggest the percent of John Ball Park Zoo members who love the zoo but don't like pets. And then the rest of the alternative was to show that it was less than 10%. So again, there's insufficient evidence to suggest the percent of John Ball Park Zoo members who love the zoo but do not like pets is less than 10%.